Let's look at final exam question number 9 in Physics Demystified, second edition. If you have the printed book, it'll be at the top of page 514. Question number 9, we're talking about a PNP bipolar transistor. This is a very crude drawing of a circuit with a PNP bipolar transistor. You can recognize the fact that it's a PNP device because the arrow points inward. If it pointed outward, it would be an NPN device. In a PNP transistor, generally speaking, the collector is negative with respect to the emitter in terms of the voltage. Now what I have shown here is a 12-volt battery. It could be 6, 9, 18 volts, but in this case, just for example, a 12-volt battery. The load is the circuit that is being controlled by this transistor. So generally we will have the positive battery terminal going to the emitter and the negative going through the load to the collector. The base is a control electrode. Now generally speaking, if the base has no voltage on it at all or has a positive voltage, we will get no current flowing through this device. If we begin to apply a negative voltage to this base called the bias, negative voltage, we'll start to see current. It has to first overcome the forward breakover voltage of this PN junction right here, which is normally about a half a volt. Once we get a half a volt negative here and we start increasing that negative voltage, we'll see more and more and more current, but only up to a point. If we make the voltage sufficiently negative, we'll get a certain maximum current through this device, and if we make it even more negative than that, the negative bias even more than that, we won't get any more current. That point where we maximize the current through this device, that state of affairs is saturation. Saturation. Now, this question is talking about if we operate a device like this in a state of saturation, it's not going to work as an amplifier for any AC signal we apply here, or at least not for a weak one. It's not going. It's because the fluctuations that we apply here will not be able to overcome this saturation bias, and we just won't see much of anything at all in the output. So an efficient amplifier will never be found in a state of saturation, but we can still take advantage of saturation. If we want to operate this thing as a switch, we can turn the load on and off. We apply the saturation or near saturation bias to this base in order to get full current through that load. This will act just about like a closed switch right here. Then if we take that bias away or apply a little bit of a positive voltage here, we'll get no current at all. So we'll be able to switch this load off. So the way that a transistor can function in a state of saturation and function well is as an electronic switch. That's choice B.